Welcome to The Explainer. Today, we're cracking open a book that takes a huge topic and makes it surprisingly simple. François Flores' The Little Book of Deep Learning. We're going to break down the key ideas right here, right now.
All right, let's just get right to it. We hear this phrase, deep learning, everywhere. It's the engine behind chatbots, AI art, you name it. But what actually makes it deep? Well, to really get what that means, we got to start a level higher.
And that's the whole field of machine learning. The big idea here is it's kind of revolutionary. Instead of a person writing code for every single possible outcome, we just showed the computer a ton of examples and let it figure out the patterns on its own.
So what does that learning actually look like? Well, the model is basically trying to draw a line or a curve that connects the dots in the data it's been given. The real trick, though, is getting that fit just right. Not too simple and not too complicated.
And this gets you into a classic problem. If your model is way too simple, it underfits. It's like it didn't study for the test at all, it just misses the whole point. But if it's too complex, it overfits. It's like it memorized every single answer, including the typos, but it can't handle a single new question it hasn't seen before.
So how does a model find that perfect, just right zone? Well, that all happens in the engine room of deep learning, the training process.
It's really just a simple, powerful loop. First, the model makes a guess. Then, it measures how wrong that guess was. We call that the loss. And then, this is the key, it uses that error to make a tiny adjustment to itself so it can make a slightly better guess next time. And it does this over and over and over. We're talking millions or even billions of times.
And the mathematical secret sauce that lets it improve? It's a process called gradient descent.
Flores puts it perfectly. You're just trying to move in whatever direction makes your error go down the fastest. And the best way to picture this is with an analogy.
So think about it like this. Imagine all the model's possible settings create this huge hilly landscape. The lower you are, the lower the error. The model is basically a ball sitting on one of those hills. It calculates the gradient, which is just the steepest way down, and takes a tiny step in that direction. And it just keeps doing that, rolling down the hill until it settles at the bottom of a valley. That's our sweet spot. Okay, so we know how it learns. But what is the model, actually? It's not one single thing. It's a structure that you build by stacking these really powerful components called layers. Honestly, the best way to think about layers is like they're high-tech Lego bricks. Each type of brick has a very specific job, and you snap them together to build these incredibly complex things. And that stacking, that's where the deep in deep learning comes from. You're literally building a deep stack of these layers.
Now, one of the most famous Lego bricks is the convolutional layer. This thing is an absolute superstar for images. It scans an image with these little filters looking for patterns, like an edge, a bit of texture, or a curve. And because it scans the whole image, it can find a cat's ear, whether it's in the top left or the bottom right corner. That's what equivariant the translation means.
Now, for another game-changing brick, the attention layer. This is the magic behind all the crazy good language models we have today. It lets a model look at a whole sentence and decide which words are most important to understanding another word, even if they're really far apart.
So how does it do it? Well, for a given word, it creates something called a query. It's basically asking a question. Then it compares that query to the keys of all the other words in the sentence to see which ones are the most relevant. Once it finds the best matches, it pulls in their values to build a much, much richer understanding of what's going on.
So the whole point is this. When you start snapping these different Lego bricks together, these powerful layers, you can build the famous, iconic architectures that are really driving the AI revolution.
And here are two of the biggest ones. On one side, you've got convolutional networks, or convnets, like ResNet. They're built on those local filters, which makes them absolute masters of anything to do with images. On the other side, you've got transformers, like GPT, built on that global attention idea. And they have totally changed the game for language.
So if you peek inside a ResNet, an image flows through these stages of convolutional blocks. At each stage, the image itself gets smaller, but the number of features the model is tracking gets bigger. It's learning simple things first, like edges, and then combining them into more complex things, like shapes and objects, until it can make a final call.
A classic transformer is a bit different. It has two parts. The encoder reads a whole sentence at once, and using that attention mechanism, it figures out the deep context of every single word. Then the decoder starts writing a new sentence, one word at a time, while constantly paying attention to the original sentence and the new words it's already written.
Okay, so we've gone through the theory, how they learn, what they're made of, the big blueprints, but what's the payoff? What can these super deep, super complex models actually do? This is where it gets mind-blowing. First up, object detection. This is the kind of tech you'd see in a self-driving car. A model built on a ConvNet can look at a crazy busy street and in real time just instantly draw boxes around every car, every person, every stop sign, and know exactly what they are.
Then there's text generation, right? The magic behind something like ChatGPT. But what's really wild is how they learn new things. With something called few-shot prediction, you can teach a huge model a totally new skill, like analyze these reviews for positive or negative feeling, just by giving it a few examples right in the prompt. You don't have to retrain the whole thing. It's incredible.
And finally, you have these unbelievable image generators. They're powered by what are called diffusion models. They literally start with a screen of pure static, just random noise. And based on your text prompt, like a photorealistic astronaut riding a horse, they slowly, step by step, remove the noise until a jaw-droppingly detailed image emerges out of thin air. So we've gone from a simple idea of learning from data, to the Lego bricks, to the blueprints, and all the way to these incredible creations. But the real takeaway, the thing to remember, is that these models are just a reflection of the data we give them. They learn what we show them. Which leaves us all with a pretty big question to chew on. And that's all for this explainer.